So here's how we would do the expected value of absent employees. We already have a list of probabilities for each value of x. So I'm just going to do sum product and select all the possible values for x, comma, their probabilities. And I get an average or expected value of 3.066. So basically I would expect about 3 to be absent on any given day. That's a different way of saying average of 3. Okay, so we'll continue on. Using the same data, the following is the distribution of absent employees again. What is the probability of having 3 or more absent employees on any given day? So again, you're just adding probabilities here. I would add the 0.34 plus the 0.22 plus 0.08, 0.019, and 0.001, which would be easy if my data is already in Excel. Okay? So the answer is 0.66. Okay, so let's turn to binomial distributions. We've done some foundational material about discrete distributions in general, but sometimes we have binomial distributions. And the way to tell if we have a binomial distribution is we have a fixed number of trials. So basically, a classroom of 30 students, my n is 30. I flip a coin 10 times, my number of trials is 10. I observe on 10 days, my n is 10. The trials are independent, so when I flip a coin, I know that if I get heads 12 times in a row, that's not going to change the probability of getting heads on the 13th flip. So basically that's the same here. Is the trials are independent, they're not going to impact, the probability of one thing is not going to impact the others. So the probability of someone being absent is not going to impact the probability of the next person being absent. There's only 2 possible outcomes in this case. So something like gluten allergy, no gluten allergy, Twitter account, no Twitter account, defect, no defect, sale or no sale. And the probability of success is represented as pi. It's not the same as 3.147, but it's pi, and that's the probability of success. This will make more sense once we see some problems, but basically a problem will give you a probability of one of the 2 things occurring, and that's going to help because that probability is the same for each trial, and it'll help you determine the probability of all these different values of x, like having 10 defects versus 25 defects, or 10 sales versus 16 sales. Okay, so for any binomial variable x with that n number of trials and pi is the probability of success, here's the equation that we have Excel for. I like to show the equation sometimes because it's so nice to see that Excel is doing this for us. And I used to teach this when we had to do it manually. Okay, so let's look at a problem so we can dive a little deeper into this. 4% of the population are allergic to nuts. In a class of 30, find the probability that 2 people are allergic. So notice the 4% are allergic to nuts. Notice that we can have allergic or not allergic. So there's 2 events, and I'm given a probability for one of them. So that's an indication that this is a binomial problem. I also have a max number of trials, the class of 30. So basically that's the information I'm going to need. That pi, 4%, the number of trials or sample size, 30, and the probability that I'm interested in, the 2 people are allergic. So I'll demonstrate that next.